In this video, we'll once again be applying the fundamental theorem of calculus to evaluate the area under the curve of this function from 0 to 3. Now, I'm going through a problem that looks similar to this because we need to make sure that we still understand the notation that we're going to have to use. Now, if I want to find the area under the curve is the integral of f of x dx from x equals a to b. This is the notation for the area under the curve. Now, given that I'm trying to go from 0 to 3, I'm going to start at 0, I'm going to go to 3, and now my function is this 2x squared plus 3x minus 1 dx. Again, don't forget that notation of dx. I also notice I put those parentheses in there. They don't need to be in there because the dx tells me when the integral is ending. So, when I evaluate this integral, my goal first is, again, one more time, to find the antiderivative of each individual term. So now, again, one more time, I'm going to take the antiderivative of 2x squared, which means I have to increase the power, and I divide by that power. Any constant, just like with an integral, that constant can be pulled out. Okay, when I say pulled out, I mean it's pulled away from this x squared, and I'm going to treat it as two separate pieces. Now, let me show you this format. You do not need to write this format on any of your work, but it is helpful for you to understand what it is we're doing in our minds every single time we take an integral. We are, in our minds, seeing this as three separate integrals. An integral from 0 to 3 of the function x squared, with the constant being multiplied by that. The integral of x, with the 3 constant being multiplied by that. And then this minus, again, the integral of just simply 1 dx. Now, if we view these details in this order, again, what is the antiderivative of x squared? Well, we did that in the last example. It is x cubed divided by 3. Again, increase the power, divide by the power. That thing is still being multiplied by 2. I'm going to go ahead and put that right on top of that fraction. And then this is going to have bounds from 0 to 3. But I'm going to hold off on doing those bounds because over here, the next term, if I increase the power of x, I get x squared. I must divide that power by 2, so I'll divide that by 2. And then again, this 3 will simply just carry on down. Okay, and then I'm going to have minus, and the integral of 1, well, if there is no variable of x, then I have to attach a single variable of x. So I'm going to go ahead and just put an x there, which is technically x to the 1, and I'll divide by the power of 1, which will not change that at all. All three of these terms are evaluated from x equals 0 to 3. So I'll just go ahead and put that again, half bracket, and I'll leave out this side bracket, and all three of these terms are being evaluated at 3, and then at 0. And when I say that, I'm going from 0 to 3. I'm going from 0 to 3. But the way that I'm evaluating it is I've got to plug in the upper bound first. Okay, that's the upper bound first. And subtract from that, me plugging in the lower bound. Now you'll notice here in this particular example that plugging in 0 here gives me 0. Plugging in 0 here gives me 0, and plugging in 0 here gives me 0. So I'm going to have a nice big 0 term. In your work, never leave that term out. If this is 0, please check all of the terms in here and ensure that all three of these terms, when plugging in 0, gives you back 0. It is not always the case in the algebraic work that that's going to occur. So we're going to go ahead and account for that, covering the fact that this is equal to 0, allowing us to make sure we don't make any silly mistakes later on. So my last step, and I'm going to go ahead and move it over here, is to simply evaluate. Well, I'm going to have 3 to the power of 3 divided by 3, so I'm going to cancel out this 3. I'm going to cancel out 1 power and change that to a 2, making this 9, 3 squared, 9, times 2, being 18. So this is equal to 18, that's the first term. Then I have 3 times 3 times 3, that's 27 over 2, so I'm going to go ahead and rewrite that term down, 27 divided by 2. And then finally the minus 3. Okay, combining as many like terms as possible, this is going to be 15 plus 27 over 2. And just to make sure that this is a nice, clean, simple, straightforward fraction, this is the same thing as 30 over 2 plus 27 over 2, and therefore 57 over 2. So the exact area under the curve of this quadratic from 0 to 3 is 57 over 2.